Welcome to a Sacramento L5 Society Space Talk. You can find more space talks at the link on the screen. And please welcome LALITHA MURALI.
Good evening, everybody. My name is LALITHA MURALI. I am a STEM and gifted and talented coordinator for a public school in Milwaukee, Wisconsin. A couple of years ago, I got interested in space because I did a workshop with the Wisconsin Space Grant Consortium. And then they said, oh, if you are doing something related to NASA mission, you can submit your proposal. And if your proposal get accepted, you get to go to space. That motivated me. Who wouldn't want to go to space? I said, I want to go to space. Let me go and brainstorm with my students to see what kind of proposals we can send it to space. At that time, my students were just using the little bit of sensors, microcontrollers, creating oxygen and hydrogen sensors. The program is already in the web, so they have to just do that. It's like a scratch program. And then they said, one of the students said, in ISS, the space classroom is, the space is like a classroom, so during that experiment, those students were just going to different classrooms to test the CO2 level in the classroom. And then they noticed that if there are more people, like 20 or 30 people, the CO2 level was higher. And then if there's nobody, the CO2 level was, small. And they said, oh, this will be very interesting for NASA. So if there is CO2 redistribution, or if there is a CO2 leakage somewhere, they can know that what is the level of CO2. Why can't we submit this proposal? We didn't know anything about it. It was just our idea, and then we submitted it. Guess what? Our proposal got accepted. So they said, how are you going to do the experiment? So the kids said, oh, we cannot do with the one sensor, so we need to have multiple sensors. And then if there is a CO2 redistribution, how are we going to do? We don't know any program. And I don't know, I am only a facilitator. I just brought the idea and I submitted it, so I am not an expert. Like Ed said, he just learned it. He became a Arduino specialist, so I didn't know anything about it. I just reached out to the local universities, some undergraduate, graduate students. Everybody came on board. The whole community came on board. The vice president of NSS, Lynn, and Francis, they both came to my classroom, and then everybody was on board, and then the kids were able to get some help to create the program. And then everything was done. So then I was about to go to zero gravity flight to test that, At the time, we had a monthly meeting with the Wisconsin Space Grant Consortium. There were 4 educators selected for that year to fly their experiments in a zero-G flight. I was one of them, but the other 3 teachers did something cool, like a round plastic ball or with some colorful liquids. Everything was colorful. When they were able to show like this in a video, we could see the color. But mine is very, very simple, a plain box with the Arduino. So I had this CO2 bike sensor. So when I release it, the air will come, and only the micro SD cards will record the data. And after I come back, I'll have to put it in the computer to get some data. I know mine was a little bit cooler in the theory, in the document, but nobody will be able to see. People will be able to see only a small white transparent box from me. So I was a little bit disappointed. I thought, oh, mine is not as exciting as for others. If we show this from space for the kids to see, it's not going to be as exciting. And so I was talking to UW-Madison professor, and he said, LALITHA, you are wrong, because I know that there is a company called Teledyne, and they manufacture FLIR cameras. Those cameras, one of them specifically made to visualize CO2. So if you use that camera, you will be able to see CO2 like a blue color smoke. So you can visually, so yours will also be colorful. And I said, really? So as soon as I disconnected the call with him, I called that 1-800 number. So it's a Kerma, I think, the exact person who's in charge picked up the phone. So I told him that I'm an educator, I'm doing this, blah, 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 I'm going on zero-G flight. Is it really true that you have a special camera that we can visualize CO2? He said, do you want me to come to your classroom? That's what his answer. I said, really? Can you come? He said, absolutely. So he flew in from Alabama or somewhere, I don't remember, or maybe California, with his assistant with not one camera, multiple cameras. So the kids were so excited. They tested their experiment. They could see the blue smoke coming out of their experiment. And they went down to the band room to bring all the instruments, and they started playing so they could see the blue smoke coming out of the experiments, the instruments. They were extremely excited, and those people stayed for more than 2 hours. And then afterwards, they said, okay, it's time for us to fly back. Then one of the kids asked that, thank you for bringing, but if we want to use this for our actual experiment when my teacher is in space, would you be able to give that camera? Do you know how much the camera costs? Approximately
$7,000.
$100,000.
Oh my gosh.
Ooh.
So
Oh my
when
gosh.
he said that, I said, I am a poor public school teacher. I don't have that kind of money. So if something happens, if it breaks down, you cannot ask me. I don't have money to pay you back. He said, don't worry, we will collaborate with NASA and we will have an insurance, so it's not a problem. We will send the camera to you. And I'm so thankful to Teledyne. They shipped the camera to my house a week before my flight. And I took it. My experiment was so colorful. The kids had a blast. I work for a Title I school district, so kids have never done experiments like that. Even the thought that they created something, their idea was used by NASA, and the teacher was able to go fly in the zero-G in space, and the kids were able to see the experiment. That was mind-blowing. And the Wisconsin Space Grant Consortium asked somebody to follow me and my students from the brainstorming session until I flew in the thing. And then they came back last year during the end of the school year, first week of June this year, to come and interview those students. Those students are in high school now, that how this one small experiment impacted them. So every kid, there were 24 students who participated from 6 through 8. And then we picked 6 or 7 students who were the main leaders of this program. And they came back and they shared that how they all want to go in the STEM field, how they are pursuing their interest in the high school and beyond. It was really amazing. So that documentary is going to come out soon. So once it comes out, you all will be able to see. It has all the people who came and helped me make my students' idea come into reality. So that motivated me to become a NASA ambassador. I started doing more NASA things. I went to the NASA Space Camp, and I attended lots of liftoff and other programs. I became an NSS ambassador. Since then, I'm bringing every year at least a couple of students to come to NSS conference to present. That is how it started. And again, I presented this year with some of my students, and then Ed and Joe and the society invited me to come and share our thing with you all. Thank you for the opportunity. So I'm going to share. So this is the presentation gave by my student at the NSS conference this year. So every year I do some basic programs, and then I add on more NASA programs. And this is this year what we did, this past year, school year. So let me share.
Okay, let me.
Oh, you need to, yeah.
Let's see. How do I do this? Oh, yeah. Okay, there we go. Okay, you can share. It says.
Yep. Okay, sorry.
Yep, we see your screen. Calendar.
Okay, I think I need to, sorry. I need to open that before I stop sharing.
Oh, what an inspiring story. And how wonderful that your students are continuing to participate.
Yes,
Yeah,
and you
I
hear it
have
all.
had,
Just one thing, just before you start, you hear it all the time that just one event in a kid's life can turn them all around like that. It's great.
can you, oh,
We're seeing a slide right now, so
oh,
it's
you
good.
are? Okay.
We're seeing space education.
Okay, I couldn't see. Let me see. Okay. So this is our students' space journey. Why space education? So space education ignites STEM interest, and the research shows that students who are participating in these hands-on space-based projects, they demonstrate a significant boost in critical thinking and STEM comprehension compared to other traditional methods. And it fosters interdisciplinary skills. You will see when the documentary comes out how those students were motivated in various fields, higher level math, physics, engineering, computer science, biology. And also it teaches students teamwork, how, failure is also part of engineering and the project management. Of course, the technological innovation, so it connects students to the aerospace industry, and it builds the workforce needed to innovate our space technology, climate monitoring, and deep space exploration. It inspires global citizenship. Studying Earth from the perspective of space definitely broadens perspectives, fosters empathy, and creates a stronger sense of environmental awareness and global citizenship. So this past year, every year there will be some programs that will be continuously common. Then I add on more new programs. So this year new was ExoLab 13 Mission Mushroom. So it's a program by Magnitude.io. And the kids were given a mushroom kit, and they were growing mushrooms because NASA is working on how they can provide mushroom as food to astronauts because it has all those nutrients, So the kids were so excited to see how easy to grow mushrooms in the classroom. And then the other new program they did is Algae Academy, where students cultivated, monitored algae growth to assess the potential for carbon sequestration and oxygen production. And every year we participate in the NWE SSP, the NASA program. That's a whole curriculum I follow every year. This year it was Earth to Venus Artemis mission. So it's the whole program. Kids do 10 different NASA missions. Tomato Spear is another one that every year my students participate. In the fall and the spring, they send some tomato seeds, two different types of seeds. One type of seeds went to the space, one did not. So the students grow. Each student will get both types of seeds, and they grow, and they have to come up with the hypothesis, and then after growing, they have to come with the conclusion that which one went to space, which one did not, and why. And another new program that my students did this year is the world's largest analog mission. So we were combined with a crew, Artemis crew, and then they were doing the same exercises the astronauts were doing, and then growing plants the astronauts were growing in the center. I think we were combined with the lunar mission, and there it came in this year's National Geography magazine, so our the whole how so many students from across the world participated in this world biggest analog mission. Our school was one of them. Of course, DataBot sent me just one DataBot to use the mushroom growth this year. So Robert Grover and the kids were excited to, measure their algae and mushroom growth in the classroom. Another one is the ST rockets. Kids always have a blast to launch the rockets. Thanks to ST rockets for sending, a couple of rockets for our school to launch. And also we do the water filtration systems, and the kids every year participate in a future city STEM competition where using the recyclable materials, they create a whole new city, futuristic city. And this year theme was agriculture, so agriculture-based cities they did. These kind of interdisciplinary approach foster 21st century learning skills like communication, systems thinking, technical literacy, and definitely prepare our students of next generation of researchers to support human life on the moon and Mars. This is the ACE project I was talking, world's biggest analog mission. So I was one of the 38 mission educators worldwide to lead this initiative with the WBA mission team. We planted and compared seeds that traveled to the International Space Station with the control seeds that stayed on Earth to study germination. And we did a 2-week analog mission experience focused on understanding the impact of extreme environments on physical fitness. So for 2 weeks, we did various fitness exercises, logged in our logbook about how we felt after the exercises. The goal was to test a hypothesis related to fitness in a simulated space environment. So you can see my students, growing the seeds in the hydroponic system and also under the grow light. So these are all the physical exercises they were doing and logging their, experience and feelings. So the next one was, this is the one I was talking about, NWESSP. This year, the theme was roads from Earth to Venus. We completed missions like creating mission patches, modeling moving carbon, investigating atmospheres, and capturing data from afar using drones, and of course, ROVing for detailed data and presenting our missions at conferences. So we use the Lego Spike Prime Kit to build a rover that can go through a map. And we had 2 designs. One of them was a car that could go up slippery ramps, and the other one was made for off-road. The rover that went up the slippery ramps did not work well, so we built a different one which had the steering like a car. So let me see whether I can show you this video. I need to stop here, and then I need to share the video, I think.
We started to see the video. There we go. Yeah.
I don't know, sorry, this for some reason the sound is not coming. So the kids are excited to show their rover. So it is one of the NASA missions. It has to go through that map. So they are they just figured it on their own. If you ask me, Lalita, how do we do it? I don't know. My goal was to bring them the opportunity, give them the map and give them the Lego robot. And these are 4th, 5th, 6th graders, so they figured it out. So this is one of the videos. And let me go here, stop. Go to the other one. Sorry. That's not one. Technology, let me tell you. This is, just hold on.
So you focused on middle school kids?
Yeah. So I always organize a STEM fair for the community. So these are the students who went little above and beyond. So the one that you saw was a simple one, and look at this kid who came up on his own. So he made it something advanced, and then he was doing a little bit of a lever that can, make the rover move. And so those are the 2 little videos, again, if you ask me, how did you do it? No idea for me. So this is the map and the rover. And then this is an ESL student who does not speak any English, but she was so fascinated about rocket And then she so willingly participate in our NASA STEM club. This is her mission patch, so she participates and she loves all these little projects. That shows that space is for everyone. Anybody can do it. The another new project I talked about is the Algae Academy. Kids learned about algae because we learned how we are interacting with the algae daily, so in our toothpaste, and the kids were so excited to see on our daily, everyday products, we are using algae. And they had an opportunity to cultivate live algae and monitor their growth. And they explored the different algae species under the microscope. Because why algae? Algae is critical for space missions, and it acts like a highly efficient biological tool. It can convert exhaled carbon dioxide into fresh oxygen, process wastewater, provide a renewable source of nutrition. Of course, algae produce 80% of their oxygen from the base of aquatic food webs, and we offer sustainable solutions for climate change mitigation. It's also used as renewable biofuel and for medical research. And so the kids were so excited to look at their algae, and so making the algae. Another new project we did is the magnitude.io. And so it's a fantastic opportunity for the kids to learn about mushrooms, learn about cloning, fungal growth, and then carbon cycles. Why mushrooms? They are important for deep space travel because they provide sustainable nutrient-rich food, offer radiation protection, and can be used to grow living habitats. Their ability to thrive in extreme conditions makes them one of the most useful resources for long duration missions to the moon or Mars. So you can see the kit, how they were growing mushrooms. It grew so beautifully. And then the kids used that little agar plates to grow mushrooms. And then they also, end of the year, used their sock with the coffee grounds, and those mushrooms were growing. Everybody took a pair of socks home, to grow mushrooms at home. So this, I reached out to the local University of Wisconsin-Madison, fungi specialist. He came to my classroom one day, and then he taught us about mushrooms. And then he invited my students to come to his lab. And then those students went, and then they were able to use his lab to do the experiment. So the kids hydrated, monitored the official substrate bulk until maturity, tracked the life cycle using the DataBot tool, then extracted the inner tissue from the harvest, transferred the cuttings to agar plates. Those things, they did it in the UW-Madison lab. Then we transferred the colonized mycelium to the serialized grains. We mixed the grain spawn into the new bulk of substrate. And then the kids created the sock bag with the coffee grounds and transferred the mycelium. It was a fun experiment. And then he said, we are welcome to come every year because that is the undergraduate course he teaches at UW-Madison. And then he had an opportunity for his students to present at the fungi lab, and he invited the middle school students to come and present as well. So that was a fantastic opportunity for my students. So I took these 9 students from 4th to 8th grade. I had 4th graders, 5th graders, 6th, 7th, and 8th graders present at the expo, Fungi Expo, with undergraduate and graduate students at UW-Madison. So you can see the kids doing the experiment, and then they were presenting. Of course, ST rocket launch is always a popular thing to do. So it's, kids learn about Newton's third law of motion, and then how a rocket needs a thrust, and then comes from the engine, and, so all those basic 4 Bernoulli principle. And then it's such an amazing, exciting thing for kids to do every year in our school. And yeah, everybody got to, launch a rocket with a partner, and then they just measure, so they are so happy. This is the end of the year we do every year. Another thing we did is paper airplane, so the kids love to create paper airplanes, and then using the motorized, it's a little small Amazon power-up kit I bought for them, and then they were able to attach the motorized propeller to, fly, and they they just were flying for an hour nonstop. So because it helps them with the concept of distance, measure how far the paper airplane flies. They had so much fun doing this activity. So this is the kids doing the paper airplane, building, learning about the Bernoulli principle. So another new program we did is we took some students to Drone Academy program at the Carroll University in Wisconsin. So they have a huge drone program. So then since our school is Title I underrepresented students, so I was able to take a couple of 8th graders to go and learn about drones at the college. Why drones? Because they perform tasks that are dangerous or dull for humans. They provide critical real-time aerial data to enhance public safety. They are crucial for space exploration, because we can use them to explore an area to determine enemy positions or weather conditions. So the kids built drones using the drone kits and listened to guest presentations from FBI and local law enforcement. And we practiced a simulated rescue mission where we used drones to deliver small medical kits through parachutes to a target. So this is kids, underrepresented kids. I took them, and then they built this drone, and then they are flying the drones. Another new thing I saw online was the Project Hail Mary Challenge. So the students are supposed to design a 2-module rotating spacecraft that generates artificial gravity, inspired by the movie. I don't know how many of you had a chance to see the movie. It's a fantastic science fiction novel and film. And we collaborated with the UW Milwaukee physics department, and the kids learned about artificial gravity and space station. And the kids applied the engineering and physics design to build a model of a rotating space station using a 3D printer. So we submitted our proposal, but we didn't get selected. But it's a fantastic opportunity for my students to learn and do something. So this is me watching the movie, and then this is the UW physics department person who came and taught the students about this. And then this is the kids design. So even I think they said 2-module design, and the kids decided they will have a central one, and then the 3 rotating things, that can generate the artificial gravity. So this is our design, and the kids built it. That's a fantastic experience for them. So, and as I said, this was presented at the NSS this year. I love bringing them to the conference because it empowers them to take ownership of their education, deepens their knowledge, and develops communication and networking skills. And this transforms students from passive learners into lifelong learners. Thank you. And yeah, so that is what I did this school year.
Excellent. Thank you very much. So rich, so many programs. We appreciate that. So questions?
And I am really excited because Ed said he would be happy to help my students learn the Arduino next school year. That is going to be new next year, so because the simple one opportunity, it's sparking interest in kids, so yeah. We need space enthusiasts and people who are experts in this field to come in, because as an educator, I'm only a facilitator, and I work for a Title I public school district, and funding is a problem, and I'm not an expert in space, but I am a facilitator. I bring in the opportunity and I bring in the experts who work with. It's a collaborative effort. Together, we could make a difference in our community.
Excellent. Thank you.
Yeah, that's great. And just FYI, everybody, at least in California, Project Hail Mary is now on Amazon Prime with no commercials.
Yeah.
So it was supposed to come out in April on Prime, and I couldn't wait, so I saw it in the movie theater, and then with my husband, and then he just watched it this past week. It's a pretty long film. It's like 2.5 hours, but it's really good, and it doesn't cover half of the book, right? In terms of its
no.
The book is better. But
I took my son and grandson when we were visiting in Arizona in May, and they both absolutely glued for the whole 2.5 hours.
Oh, that's great.
Well, the thing about for STEM education, the book is an engineering treatise half the book is engineering, and it's really,
Yeah.
really cool. Yeah, really cool. Because the guy wakes up and it's like, where am I? And then he notices that stuff is falling too fast. And he's saying, wait a minute, this is too. And then he measures gravity with his instruments. And he says, I got to be on a spaceship because I got 1.5 gravity here. Wait a minute, what's going on? And the whole thing is logical like that. It was really cool.
And The
That was the
Martian
best
is the
part.
same. The Martian is just essentially a series of engineering challenges, even though he
Yeah.
says it's science, but it's engineering. And to me, the Hail Mary, which I took a while to read, and then when I read, I thought, oh, this is fantastic. But it's really, it's the Martian with an alien sidekick.
Yeah, yeah.
Yeah, so he has a friend to talk to, which is great.
I actually went back and read it twice almost immediately. It was really,
Oh,
really
after you saw the
cool.
movie?
Yeah, and then I read it again. I mean, I think I even read it twice before the movie. It was really, really good. Yeah.
Well, Letha, it's amazing. You have so much energy to share with your students, and
Yeah.
so many opportunities. It's so great, and also taking advantage of, I think people at the universities, at least in my experience, if they have time and if they're tenured, they have more time. But they want to express and share their own interests in science. And so, as a facilitator, if you can find those people, you can do that job so well. So that's really fantastic. And yeah, and I just I think both you and Ed mentioned how if you catch one student or give a student one opportunity and show them they can do it, it's so cool. And with these kits and Arduino One parts you can order online for just a few dollars. I mean, less than getting a cup of hot cocoa or something.
Yeah.
You can build these sensors at home, and it's so fun. I mean, I've had fun doing it,
Mhm.
And I've built more expensive equipment, but it's like so fun to have a little breadboard and make sensors with lights and then have them work. It's really
Yeah,
great.
it's really great.
Yeah. The FLIR camera, it's funny, I said $7,000 because that's about the cost of a thermal camera. So obviously a CO2 camera is more sophisticated, but it's even $7,000 is not really a play toy. So
Well, I really like the image of looking at the band playing their wind instruments.
yes,
That I would want to see. I really want to see that.
yeah, I know. I want to see that too. That sounds great.
Let me see when you guys are talking, I will find that picture and share.
Oh, cool. That'd be
Yeah,
cool.
that's really great. But Chris, did you what you were telling us what you taught when before you retired? Did you interact with any STEM educators?
No, I taught adult career
Oh.
technical education.
Okay, does that mean when you say career technical education, do you mean like life skills like accounting and
Yeah, it is. It's life skills.
Yeah.
And they were adults that came to the adult school to do it. And what I taught was I actually taught 4 classes in one classroom simultaneously, which were medical terminology, medical billing, medical coding, and electronic health record. And of course, the way I did it was because I had all the curriculum on a computer. And the students also rotated in and out. It was exciting. I loved doing it. And I've been retired for 8 years now, and I still have students that stay in contact with me.
Oh, that's great.
So
Well, that sounds actually really valuable to have skills to be able to navigate and understand some of the healthcare
Yeah.
documentation, bureaucaucy, just medical
yeah,
policies, all that
bureaucracy
stuff.
for sure.
Yeah. Oh, wow. No, that's okay. I'm going to ask for your telephone number. No, I'm just kidding. That's great. So, are you in Sacramento? You said you're near the Rockwell Club, and I looked. That's in Downey, California. Is that where you live?
Yeah, no, actually, I tell people I'm near Los Angeles, but I'm actually up in the Mojave Desert,
Oh, wow.
in a really small. Well, it's a nice town, but it's in a rural area. I When I retired, I was living in San Diego County, and I was able to buy a house on a golf course, so of course I did, and it's nice, but it's hot here. It's hot, very hot.
Yes, but you probably have air conditioning.
Yes,
I was
yeah,
talking with
but but nobody can afford to use air conditioning now. When I came here, it was like, well, who cares? But now the price of electricity has gotten really high. But we manage. We manage.
Yeah, I was talking with a colleague yesterday who lives in London, and I said, "You look so refreshed." So I just took a shower because I thought it would help me cool off. It was easy for
Yes.
her, and she said, "I just feel it. It's over 100 degrees there, and no one has air conditioning." So,
Yeah, really.
yeah, it's just very hot.
Well,
Right
we have it here. We just use it very sparingly. But and I think it was 105 today.
Wow.
And it's only going to get down into the 70s at night. Usually you get that nice cool off. Well, we don't get a whole lot of it.
Yeah,
But
wow.
I do put the air conditioning on in my bedroom at night. I've got to sleep.
Wow, that's great. Well, Letha, when does your school start again? When does the term start?
August 17th. So
Okay, so you have a month to go. And how much lead time are you, I mean, to get funding for these activities? That's probably on you to right away and get the support and bring people in.
I always look for funding. If
Yeah.
there's an opportunity, like, like when I present, I then ask for money. So like that, when people I go whenever I present, even in any gatherings, I go, and then when I say that this is what I do, in any way you could support, even to come in through Zoom to talk to my students, So those opportunities, because the kids love that, they don't want to hear the same thing from the teacher, same thing again and again, something small, So like I was talking to Ed that every time I see that in Wisconsin, we have this balloon, a hot air balloon, and then the sounding rocket experiments, but I don't know how to do that. And he said, "Oh, this is something you can send in hot air balloon." I said, "That's the project I can do next year." The kids can work with Ed, and then they can send their experiments, Then he said, "Yeah, I will be happy to come and coach them." And that's what I want to do.
Yeah.
And then I asked people to come
Showing
in.
my thing. Yeah.
Yeah,
So
that's
anyway.
so cool, Ed. Wow.
Yeah, this is a prototype. I got to make it smaller, and I'm going to make a video on this. One of the things that I had to do here was I soldered it all together once and didn't work at all. And so the problem was I had to build a test program that allows me to test each component as I plug it in. So I can now, from this breadboard, it's working. I can plug in the nano, test it. I can plug in the LED, test it. So if I make a soldering mistake at the LED time, I don't find out after I've soldered the whole thing together. So that's the kind of thing I want to try to teach the kids about how to solve the problems. You've got a goal, but you don't get there right away. And if you don't get there, what do you do to get there the next time? That's the real thing I'd like to show people.
Yeah, that's great. So is the link to your YouTube, because don't you have some link on the website already?
Yeah, if you go to the Sacramento L5 Society website and look for the balloon projects, you'll see links. I've got a number of links up in there too. One of the other important things that happened there, and I described this in one of the videos, is that it's really great. You learn electronics, you learn programming, you copy everything from the Arduino kit, the Arduino kit. But then if you try to go out on your own, well, then it gets interesting because it took a long time to get the camera to work. And so I kind of describe how I had to go back and forth to ChatGPT for weeks before I could get a working camera program. Because I learned a whole lot about JPEG internals and all sorts of stuff. But my point there was that if you're doing it on your own, Arduino's great. It works. That's perfect because you get the concepts. But if you want to do something new, as your kids are showing, they're doing all sorts of new programs and new robots. But if you want to do something new, then you get into real engineering, which is, hey, that doesn't work. We've got to do something now. What?
So are you going to go online and be ask Ed, and then
yeah, that'd be great.
That's really cool. Wow.
Yeah, I'm available pretty much any day, 5 to 7. So yeah,
I found it, but for some reason I couldn't airdrop it to my computer. I'm going to play from here. I hope you guys can.
That's interesting. Yeah, good way.
Oh, I see the camera. I can see it. The blue smoke.
Yeah, that's how much fun you can make science and engineering. That's great to see.
Wow, you probably refine it such that you could, perfect your embouchure or whatever you call the lip position on the tongue. And then,
It's embouchure.
Embouchure based on how much
Embouchure.
CO2 is coming. Yeah.
They went and brought all types of instruments and they were playing for 2, 3 hours. Those Teledyne company people were staying in my classroom. That
Yeah,
was
that's
so
great.
awesome.
Wow, that's great.
I have every year the parents say that my kids are excited to come to your class. So every year they say we cannot, I wonder what we are going to do this time with Miss Morali. So that's what I tell teachers too, that we need to bring in these so many hands-on activities with kids, real life, authentic, so that they feel good about themselves. Simple things. So.
Lalitha, there's something called a bot ball. Have you heard of that? And I'm gonna put it in just bot ball. And it's actually they're bot ball competitions, but it costs money. So if you come from a school, you need sponsorships, right? Because what you do is you buy a kit. I mean, and usually they're clubs, and the students get help with the teachers and parents, right? So it's a group project, but you get a Ziploc bag with a kit, and that's a robot. So you can build your robot based on the parts in the kit. So you have a little bit of latitude, but it's really you're supposed to limit yourself to what's in the kit. And then they have regional competitions, and it's usually timed. You have to, you show that table with a map, so they might have to pick up a ball and put it in something else, and they try to theme them so they're kind of space mission, to move the oxygen spare to some other habitat or something. I mean, they try to make it creative, and your students might be something your students could do. I mean, so I actually went and spoke at one of these competitions once, and it was so inspiring talking to all the kids and their parents, because sometimes the parents were engineers and were involved, and other times the parents were, homemakers or bankers, and they learned a lot too. But it just the incentive to compete and make these robots, it might be cool. And I think it goes from elementary school all through high school.
Oh, that's so cool.
Yeah.
Yep.
If you want more information, if you can't find anything, let me know and I can put you in touch with the organizers.
Thank you, Jen.
Cool. I mean, when I went to speak at this competition, it was a global, they called it the Global Conference on Education, and it was a bot ball competition in North Carolina, and it was at a big Houston or Hilton hotel complex, and I didn't go outside for 3 days because everyone was in the conference rooms, actively working and getting ready for their trials, and all excited, all the teams, and everyone was you mentioned mission patches. What these kids did is they had real-time sticker or pins, little pins with the other stick pins, I guess, and they could make their logo on a pin with a little kit, a little printer or whatever, and so they would exchange them with all their fellow students, and so or guests like me, and so I came home with 50 of these pins, which are in a closet somewhere. But anyways, that's something else something you could do that's faster turnaround time than a mission patch.
Yeah.
Do we have a mission patch for our chapter?
Just a little bit of an NSS logo, but not anything custom to our chapter. We should come up with something like that. That would be nice as a brand. Yeah.
Yeah, that'd be cool. We need an artist. Who's the artist? Jan, are you an artist? So I don't have the agenda in front of me, Ed, but I don't know where we are on the agenda, but
on the agenda. Well, we're just, I'm all fine having these presentations and Q&A run just as long as they need to. But I guess it's about time to wrap up the presentation portion and then start our meeting. There's really nothing controversial in the meeting, so anyone's welcome to stay, Letha, if you want to see what we do.
I have a question for Letha, and that is, Letha, this is I think the second time I've seen you, and I'm relatively new to this chapter, and You're in Wisconsin. Will you continue to be part of our chapter?
Yeah, I would be happy to. Yeah, because
We're
I
just
don't think we have anything here like that.
okay.
So
Yeah,
Yeah, you're welcome to join our chapter, whatever. I don't know how officially you join the, if you're in the NSS, which you must be as an ambassador, I don't see what the official acquisition is into our chapter. So yeah, you're welcome to come to all these meetings. We'll keep you on the mailing list. So
ask Joe to make sure you stay on the list.
yeah, we'll stay on the list. Cool. So let me see. Let me see if what happens here.
And Ed, do you live in Cupertino or do you?
I live in Pittsburgh, California. I live a ways. I work from home, so I live in.
So who was in California? Because I just saw a Facebook post that Pacific Coast Launch or something, they are starting in California, the NASA thing. So it's for educators, but they said we won't be able to pay for your transportation, but you are welcome to come and attend a 1-day, 2-day thing. Workshop in California. So I applied and I got in. Now I need to find some funding for my airfare.
Where is it?
It's in LA.
Oh, okay, cool.
Is it JPL or Caltech?
Yeah, it is some organization that just started. I just got the email today. So, yeah, so I like to attend all these things and get the resources. That's how I run my program at my school, you know. It's called, yeah, Pacific Coast Launch Network.
And what? I'm sorry. What are they doing? The Pacific Coast Launch Network.
The program, they educate teachers about a couple of NASA missions.
Educate.
And they give resources for us to do that.
Cool.
So they said they have one in-person kickoff session. So I have to attend monthly meetings, but I have to mandatorily attend one in person. One is in July, one is on December 12th. I said I cannot attend the July one. That'll be so expensive. But it's the December 12th at CMSE. I don't know what is that.
CMS.
Okay.
Center for Collaborative Education. And yeah, it's happening there.
CMSE, Center for Collaborative Education. It doesn't quite match, but anyway.
Neat. Okay, so our regular meeting then, that's the end of the Q&A for the presentation. So our regular meeting is the Treasurer's Report. And that concludes LALITHA's talk. See you next time. And don't forget, there are more Space Talk videos available on the Sacramento L5 Society website.